Alright, these notes are going to go into your HBS course file. So this is our next organ system. It is the endocrine system. Functions of the endocrine system are to control, regulate, and communicate. Endocrine system makes and releases hormones. So functions to control, regulate, communicate, makes hormones, releases hormones. Biomed professional associated is the endocrinologist. All right, so endocrine system and nervous system are both organ systems that communicate or that deal with communication. Both the nervous system and the endocrine system together help to regulate and control all of the actions in the human body. Nervous system, endocrine system, both together regulate and control all of the actions in the human body. Nervous system is usually closer. It's not really broad. It's an electrical and chemical communication. It's faster and specific. Nervous system, electrical, chemical. That's the type of communication. It is a faster type of communication and it's very specific. Endocrine system involves just chemicals, involves the hormones. It usually has a broad effect and it's going to last longer. So endocrine system communicates with chemicals, has a broad effect, and it's going to be longer lasting. For the endocrine system, we need a gland to produce a hormone. That hormone is the message, and that hormone can be secreted into the bloodstream or into a duct. If the hormone is secreted into the bloodstream, it's considered an endocrine gland. If the hormone is secreted into a duct and then secreted, then that's an exocrine gland. So we need a gland to create a hormone. If that hormone is secreted into the bloodstream, it's considered an endocrine gland. If the hormone is secreted into a duct, it's considered an exocrine gland. A gland is an organ that makes and or secretes chemicals. A gland is an organ that makes and or secretes chemicals. An exocrine gland releases substances through ducts onto another part of the body or outside of the body. So an exocrine gland is going to release substances through ducts onto another part of the body or outside of the body. An endocrine gland is going to release its substance directly into the bloodstream or into the tissues. An endocrine gland releases substances like hormones directly into the bloodstream or tissues. Hormones are chemical messages that circulate throughout the body and can contact all of the cells, but hormones are only going to affect target cells. Hormones are chemical messages. They circulate throughout the body and can contact all cells, but only affect target cells. So, example, we have 3 different hormones. Hormone A is only going to affect the specific target cell for it. Hormone B cannot affect the other cells. It can only affect its specific target cell. Hormone C is only going to affect the target cell specific for it. All right, so we'll have some feedback loops on that side. On the right-hand side, target cell receptors can be on the cell surface. If it's on the cell surface, it's usually going to be protein-based. So target cell receptors can be on the cell surface and are protein-based. They can be intracellular. If they're inside the cell, if they are intracellular, they're most likely going to be lipid-based. So hydrophobic hormones can cross right through a cell membrane and trigger or inhibit translation. So target cells inside the cell, that hormone is hydrophobic, and so it ekes its way through that cell membrane. It's going to go through by passive transport, and then that hormone is going to connect with its target cell inside of the cell. So intracellular target cells are lipid-based. Hydrophobic hormones can cross right through the cell membrane. When they bond with their receptor, they're going to trigger or inhibit translation. So they're going to trigger or inhibit whatever cascade, whatever kind of cell signaling pathway that's specific for them. A drug or a toxin can change the shape or block a receptor. A drug or a toxin can change the shape or block a receptor. So I have this drug, this toxin, it's blocking that receptor so my signal molecule cannot bond with it. Or here's my receptor, this drug, toxin, whatever, bonds to it, and it changes the shape. This toxin changes the shape of that target cell. All right, so you have this insert that has all, well, not all of them, but has a lot of our hormones, the gland that produces the hormone and the target of that hormone. So GH, growth hormone, that is an important one. ACTH stands for adrenocorticotropic hormone. ACTH, adrenocorticotropic hormone. TSH, thyroid stimulating hormone. TSH, thyroid stimulating hormone. TRH, thyrotropin releasing hormone. TRH, thyrotropin releasing hormone. Another important couple of hormones right here. So calcitonin, we talked about that before. Calcitonin is going to put calcium into the bones. It targets the bones, deposits calcium into the bones. That's produced by our thyroid gland. PTH takes calcium from the bones and puts it into the blood. Puts it into the blood, and so it's targeting kidneys and bones, telling the bones we need the osteoclast to start breaking down bone. And it tells the kidneys to hold on to more calcium in the waste products. So PTH, parathyroid hormone, it's going to take calcium from the bones and put it into the blood. Aldosterone, just the adrenal cortex of the aldosterone. I think we look at that a little bit more when we do our build. ADH. So ADH is an antidiuretic hormone. It is made by the hypothalamus and released by the pituitary. Hypothalamus and pituitary have a really close connection because the pituitary comes off of the hypothalamus. So ADH is antidiuretic hormone. It's made by the hypothalamus and released by the pituitary gland. A decrease in ADH means that there's going to be an increase in urination. A decrease in ADH, a decrease in the antidiuretic hormone means there's going to be an increase in urination. For people who hold on to a lot of water and they have a lot of swelling due to water, a lot of edema, they might take a diuretic, and that helps them to get rid of that water. If we have an increase in ADH, you're going to have a decrease in urination because you're holding on to more fluids. If there's an increase in ADH, then you have a decrease in urination because you're holding on to more fluids. All right, and finally, we have our dysfunctions. You can read through these yourself. One of the things that I did add, hyperthyroidism due to immune disorder. If we lower the amount of TSH, then that increases T4 and T3. So hyperthyroidism, we have less TSH and more T4 and T3. Here's our acromegaly. So we have too much growth hormone. Graves' disease, usually characterized by bulging of the eyes. So Graves' disease is an immune disorder affecting the thyroid gland. Osteoporosis, we have a decrease in the density of the bone as you age. Decrease in bone density with aging. Goiter, a goiter can result from the lack of iodine or from inflammation. Goiter can result from a lack of iodine or from inflammation. hyperthyroidism. Hyperthyroidism, overactive thyroid, speeds up the metabolism. Hyperthyroidism, overactive thyroid, speeds up metabolism. Hypothyroidism, underactive thyroid, slows down metabolism. Hypothyroidism is an underactive thyroid, slows down metabolism. I think that's it.